So we're going to be talking about a little bit of a different vein on observability here in this talk, which is how we actually observe our observability or how we look at it and cognate. So as you heard, I'm a senior systems reliability engineering manager, and I kind of started out in systems engineering and production operations and incident management. I've worked at places like Wall Street and banking. I worked at Sesame Street, literally, HBO, where we conquered a lot of dragons. Led an original SRE team at Venmo. Interestingly enough, I also have some experience as an EMT and a member of a search and rescue organization, which kind of helps with emergency management and how that applies to incident management. And I'm currently a senior engineering manager for systems reliability at a location-based ad tech company called Ground Truth, where I'm responsible for infrastructure, DevOps, incident management, and I'm currently building out these teams, so yes, I'm hiring. So what we're going to talk about? We're going to talk about how we look or how we see and visualize our observability data. We're going to explore why some time series charts were developed and some critical takeaways about them. I'm going to try and encourage other engineers to improve the data density and multivariate relationships in our observability data displays. And what I mean by this is, raise your hand if you've got a dashboard and it's got like 100 charts on. Yeah. It's very popular for our observability platform vendors to be able to produce lots of charts, but we need to be able to get them consumed better, and that's what we're going to talk about. We're also going to talk about some pitfalls when dealing with observability data, and some tips for improving our observability data presentations. So this is a mouthful, but what I really want to discuss today is about building data narratives, and specifically how we can be doing that with multivariate observability visualizations. In other words, including multiple different types of cardinality data in a particular graph rather than having them all in separate cells. This is the first supposedly known example of the attempt to show changing values graphically over time. It was in a 10th century manuscript, and it was really stuck in the back. It was part of an appendix. The appendix had a bunch of commentaries by Cicero, and this apparently got scribbled into the margins, but it got circulated around a lot in monasteries and the schools of the time. But the technique seemed to get lost after that. Now, I got to ask you a question, though. Raise your hand if you think you have a better observability chart for your system than this graph. Because this plots all 7 of the common service level indicators of the time. Everything is controlled by one of these planets, right? And if you can just graph them, you have everything that you need to know. And these guys did it not on 7 different graphs, but on one. And that's the type of relationship that we want to work to share, right? If you could come up with all 7 of your SLIs on a nice graph, you'd be doing pretty good, and you'd understand how all of them are affecting you in your daily life. So as I said, that technique got lost for 800 years. And next was kind of, we see time series data being used by a guy by the name of William Playfair. He was a kind of troublemaking Scottish political economist and statistical inventor. Apparently he also was a secret agent, but he published a book, and they must have really, titles must have had to have a lot of words in those days, but it's called The Commercial and Political Atlas, representing by means of stained copperplate charts the progress of the commerce, revenues, expenditures, and debts of England during the whole of the 18th century. The real key here is that he was using these copperplate charts. He also founded a bunch of statistical methods. The line chart, the area chart, the bar chart, the pie chart, and the circle graph. And we'll see some of that in his works. But he had this problem. He was trying to influence some economic policies. And he kind of had another problem too, which was the state of the art of data displays at the time were just these tables of raw data. And he wanted to address a broader audience that was not going to want to read dull tables. So he said that information that was imperfectly acquired is generally imperfectly retained. And a man who has carefully investigated a printed set of tables finds when done that he only has a partial idea of what he read. And so he wanted to change that. And he wanted to change that using this time series graph. And he had another problem, which was what are time series graphs? Because nobody had heard of them before. In his book, 43 of his 44 charts were time series graphs. The odd chart out is a bar chart. He didn't have data to do year-to-year measurements to produce the time series, so he created the bar chart. But he thought that this was a really shitty technique for anyone to be using, and that no one really should use it because he really kind of preferred the fact that you could get much richer data stories out of time series data. And I don't know, do you use a bar chart today, anyone? Okay, I guess he was wrong. But he had to explain how time series was going to get built out, because nobody had really heard about it before. And indeed, he says, the method has struck several persons as being fallacious because geometric measurement has not any relation to money or to time, yet here it's made to represent both. And he kind of describes this. He says, well, if a man was to take all the wages at the end of the day and their guinea coins and they stacked them up, and you stacked all the stacks next to each other, that all of that would like effectively form the time series that he was trying to describe. The key here is he's binding these metrics together: time, proportion, and amount. And this is the type of chart that he was publishing. It's the first type of chart to show imports and exports on the same chart. And we see here actually two related plots. And I want to point out, because it's very critical, that they both have exactly the same scales. And in this chart, he demonstrates the balance of trade shifting between England and the combined exports and imports from Denmark and Norway. And that's on the top. And on the bottom, we see the trade balance between England and Sweden. And what may seem evident today is he's the first person to visually use this implied delta of the two metrics to show area and value between things, right? So that was another big one of his claims to fame at the time. So let's take a look at that chart. As you can see, we've got, a time series on the bottom. They're the same scales on both the top and the bottom. And this is going to, we'll see this is important to use whenever you're putting two charts together just a bit later. He also created a really better time series chart, one that actually uses a lot of this multivariate data. It actually was, as I said, he was this troublemaking economist, and he actually sent this book to the Lords and Commons with this particular chart in. He uses this time series chart here to not just show the relationship of a single cardinality dimension over time, but demonstrates multivariate metric relations of orthogonal character of cardinality on one single chart. What do we mean by that? He's got 4 different metrics plotted on 4 different axes on this chart. On the bottom, we see time, like we would see on any time series graph. But he also includes at the top, we see these centuries, the lists of centuries there, right? On the left-hand axis, that's this side, right? On the left-hand axis, we see these wages of what he calls wages of a good mechanic. And then the bars are the price of wheat, which is a quarter of a wheat. I don't know what that is, some unit of measurement. And we see the price then on the right-hand side of the price of wheat. And then he adds a couple of other things on the chart too. He adds the reign of the current monarch at the time. And that's on the very top, these kind of bars that go across. The odd bar out there, the one that's white, is actually Cromwell. I guess he doesn't count because he wasn't a reigning monarch, but he's still listed up there. So what we saw here was the plots for time on the axis on the bottom, the centuries denoted on the top, the price of wheat with the right axis, and the wages of the good mechanic on the left, the reigning monarch on the top. We see 4 different metrics plotted on one graph. Let's steal this graph because it's actually a good one, all right? It's a reusable pattern that I think that we can reuse a lot. So for here, I've said we can produce similar sorts of charts. I'm creating a multivariate chart here, right? I've got maybe some key deployments on the top that I'm interested in. Maybe I'm measuring sprints, and maybe these are days represented. Maybe it's hours, and we're representing something else. And then I'm using the bar chart pieces to represent the average daily requests per second, and I break it out by status code. And then we see yet another metric that we care about, the latency that's on the right-hand side. and that's using the line graph. So here we have 4 different types of things all on one graph. And it really kind of helps me understand how the reaction time between volume of requests and the errors that might be happening affects latency, and how that might have changed over time with key values like deployments and things like that. You can reformat this chart and use it in all sorts of ways. But the point of the matter is that we're trying to add multiple types of variables, different types of cardinality, to one chart to form a nice, clear picture that tells a narrative story. Which brings us to probably the best narrative story graph ever. Edward Tufte declared that it may well be the best statistical graphic ever produced, and he has some good reasons for that. It's a chart by Minard, and it's actually one of a set of figurative maps that he produced, but it's his most famous. It's ostensibly also a time series graph, and it also makes use of extensive multivariate data. It forms this powerful narrative of Napoleon's disastrous march on Moscow in 1812 and the loss of his troops. It illustrates the French army losses as a time series and what he believed to be the root cause of that defeat, the cold, also plotted as a time series in a multivariate data display that incorporates 6 different variables on one chart to tell its tale. The size of the army in men, scaled and labeled, 2-dimensional location and annotations for key places, the distance traveled in leagues, the movement of the army and its direction, that's this kind of red, or it looks brown line here, and a black line for its return, the time, and dangling at the bottom of the chart here we can see is the temperature, and these start at degrees below 0. So here's a much bigger version of this chart, and you can see what's going on. We've got the troops marching from the Niemen River, which is actually in Lithuania, and they're marching towards Moscow, and the army keeps getting, dwindled down, and we see this disastrous then retreat, right? And what he points out is that the reason why he's losing so many troops is because of the temperature. We see, and let me see if I can, now I can get a mouse pointer. So we can see here, he's got documentation at the top of his chart, which is important. He's integrating text onto his chart. We see the troops' movements here. We see some little marks here to describe the size of the army at those times. And then dangling off the bottom here from these hanging lines, we see the temperature at these points. We even see right here, half the troops fall in the frozen river and he loses half of his army. There's a scale of leagues, and we can see a lot of information. And while many people debate what the real causes of Napoleon's defeat was, this is trying to make a picture, a narrative story using data that the cause of the defeat was because of the cold. And what also makes it notable is that Edward Tufte, who does a lot of writing on this, uses it to describe some of his key principles of analytic design. Things that you should be including in your data presentations. Show comparisons, contrast differences. Show the causality and mechanisms. Completely integrate all sorts of different evidence. Words, numbers, images, and diagrams. Use multivariable analysis, because most everything we really want to ever understand is always going to be multivariate in nature. It's not just one metric that goes bad. It's a series. We have complex systems. And of course, documentation, which we can never get enough of. There's a lot of documentation that he included just in this verbiage right here, including the methods that he used, the sources that he used, and how he came up with some of the conclusions and a couple of the assumptions that he made. So that's what we want to be doing. We want to be using these multivariate type of visualizations to better visualize our service level indicators and create a multivariate narrative of how that's affecting our SLOs. Because the goal of good charts and dashboards is efficient communication of complex quantitative ideas. And we've said that most everything interesting is a multivariate relationship, and that's really what complex ideas are about. Graphics are meant to reveal our data, to reveal what's in them. We call it observability because we're supposed to be seeing something out of it. So what I'd like to stress is to build better charts for on-call engineers so that they may quickly consume the information that's in them. To translate those service and system level indicators that we have into this narrative picture of an SLO decline, or maybe its improvement. Build metrics into narrative charts to include on these dashboards, and use these multivariate charts to allow these engineers to connect more of the service level indicators together just by looking at a single picture rather than a screen full of individual metrics being graphed. And of course, these are then great to bring back into your incident retrospective reports because we can speak through visualizations illustrating the problems that we have much easier if we draw a picture. And they're everywhere. I just found this graph just yesterday that somebody was using at a presentation here. It's a pretty complicated graph. It's showing a very complex multivariate relationship, and it was very important to them. And I just snapped it from somebody that was presenting just yesterday. Let's talk about some common pitfalls that distract from our good observability and our visualizations. And these are things that I actually have observed from Slack, incident reports, engineering presentations, and dashboards. We're back at that Playfair graph. Make sure whenever you put two graphs together that are doing similar metrics that we're using similar scales. I often see two graphs, latency from one Kubernetes cluster, latency from another Kubernetes cluster, and they got different scales. And whenever you go, where your eye wants to form this visual relationship between them, and it's going to allow people to draw bad conclusions. It's very confusing to engineers, especially whenever they're in the heat of an incident, whenever multiple graphs that use similar types of metrics use different scales. But it's often the out-of-the-box behavior, so be cautious about this. But skewed scales lead to skewed decision-making. Another pitfall that we see, and this one's blatantly obvious, is about shading. Just say no to shading. Prefer lines for your metrics. Again, we often get default behaviors out of our plotting tools that do this for us and do it poorly. Shading, however, is most often what we just call chart junk. It's distracting from the data that's there and the journey that the metrics are supposed to be taking. There is one case where shading does come into place that's useful, and that's whenever you have bar charts or area and pie charts where you're summarizing the variable together. If you want more on chart junk and you want to learn a little bit more about it, I'd suggest you check out this blog post from Edward Tufte's website. You can just Google Tufte and chart junk and it'll bring it up, but there's a URL and you'll find it in the slides. But if you do want to shade something, shade your grids and the other non-data ink. By non-data ink, I mean that stuff that isn't representing the data, all the other lines and markers and everything else. Also, I see this happen a lot. This was a chart I took directly out of Slack that somebody had posted during an incident. It's missing scales, keys, and other critical explanations that I needed to understand what this was supposed to be about. I don't know what this chart is charting. I don't know what the metrics are. I don't even know what the scale is because it's not listed. We don't even know what the sources of all those bars are. So we're really missing the data narrative. So be cautious whenever you're cutting and pasting in, and at least include the scales and the keys if possible. And also in terms of missing scales, we have this other problem, which is called truncated or torn graphs. We see this a lot, and this was in the Robinhood app I took out just the other day. It looks to me like the price of Amazon stock just tanked and hit the floor. But really what's happening is we're only looking at the top half of the graph. We can't see what the scale is here. Until we, in the middle image, hover over a spot on it, we see that really it's actually the price there is still close to its high, and that really, if we go down to the bottom, we really see that it's really only changed by $60. But if I look at this, it looks like it hit the floor. So be cautious when you're doing that. Now, I suppose there are some reasons why you might want to do that, and that's because maybe you want people to do more stock trading that day. Another pitfall that I see is not linking the source URL of a graph back in Slack, a retrospective, or in a report. I almost didn't include this slide, but I was having coffee with an engineer just yesterday, and we were talking about that we see this often. So I included it back in. Often, I need to get a better copy of the slide or the graph for an incident report. But it also makes it easy to, follow along at home. For those that are following along on the incidents, they might want to get back to the dashboard where the graph was created. It makes it easier to recollect that for these reports. And most importantly, engineering and science is about repeatability, and we should be able to get the same results twice. So it would allow engineers to double check our work, but also maybe steal a good pattern for reuse. And of course, it allows a confirmation of the observations that are being made and allows credibility of the evidence to be explored. Oftentimes, people post stuff and it's just not right, and you can easily determine that if you get a link back to where the source material was. Another pitfall that I commonly see has to do with percentages and averages. I'm sorry, folks, I don't think percentages are metrics. If I ask you for 30% of string, how much do I get? I don't really know, right? If it's 30% of the CPU, what size box was that? How many cores did it have? I have no clue. Percentages just really are really a waste of your time. They're not a metric, because metrics mean you're measuring something. And they're very easy to subvert. Would you alert on a 25% error rate? Yeah, you might want to do that. Except 25% error rate is 1 in 4. What if I only had 4 requests and only one of them failed? Is one failure really going to be something I want to wake an engineer up on the middle of the night for? Probably not. The other issue is averages. People say average, and really what they really wanted to mean was the middle of the bell curve, which is the median. So try using that instead, because really what happens whenever you get a mean is you have all of the stuff down at one end of the tail and the other end of the tail, and these really move where the average is, but it's not the middle of the data that you're interested in. If you really want to use something, try using P50, P75, P90, P95, instead of using min, average, and max. It's going to give you a lot more information about what's really happening. We talked about making lots of metrics on a graph to increase the data density, but let's talk about using fewer metrics and still creating better density of our data. We still get a lot of stuff that's in tabular form like this, right? And here we see a common type of dashboard where we're showing current, average, max for different servers. But we're only getting 3 metrics for each one of, or 3 values for one metric for each of those servers. You can see here a slightly different version of a similar type of a table does the same thing, but it uses something called a sparkline. Sparklines are data words. They're designed to be the size of a word so that you can include them inside text and other graphics. You can present hundreds more data points in the same size spot as a number. So here you can see we had the 3 numbers, our min, our current, our average, and our max, but we get a much better picture just by showing that sparkline. And you can stack them up to do nice comparisons. And then you can include them in your tables. And they're really easy to use, because this is probably, if I give you a 20-second takeaway from the talk, this is it. Brew, install Spark. Everyone can easily do that, right? And now you get sparklines from the command line. And now you can easily just take small bits of data and include them into your discussions. So, in conclusion, build data narratives. Use multivariate information displays to demonstrate the critical relationships between your metrics, and use that in your dashboards, on your incident retrospectives, cutting and pasting in Slack. Increase data density and increase cardinality by relating key metrics together on a single chart and using orthogonal axes for different metric types. increase data density in tables and paragraphs using Sparklines, and avoid some common pitfalls that distract from other people being able to observe good stuff out of your data. And that's it. I'll take some questions. If you'd like to reach me, you can reach me, that's my Slack here for USENIX, my email address, and you can catch me on Twitter at Colonel Mode. Thank you.